YouTube, welcome back to the Blades to Be shop and another project video. Been an exciting couple of weeks since I got the last video out, and I'll tell you a little bit about why that is, and today's video is going to be a little bit different than usual. So for those of you who are just finding this channel for the first time, normally in these videos there's a whole lot more actual machining and showing all the steps in making the part. Today's video is going to be a little bit different in that one of the interesting things from the last couple of weeks is had a major computer crash. Tried to upgrade my Mac to BigSur, and not to bore you with all the gory details, but in the process of doing that, it split my Fusion drive. My last update had been 2 weeks prior to that, so I lost 2 weeks worth of data, including about 10 hours of the video footage in making this part, because I was going in and I was uploading that to my computer over the weekend, and then on Monday when they helped me reset my computer, that's when the Fusion drive split, and it hadn't been able to run a backup all through that period. So unfortunately, lost some cool video, but it's all right. This was already going to be a little bit different anyway. I've told you all about my new Tormach machine coming, so we'll spin the camera around here in a minute. Been prepping the shop a little bit for that. But again, today's video a little bit different in the fact that we're not going to have quite as much of the hands-on machining, but I did use Fusion 360 to design this part. And we're going to have a chance to walk through the design on Fusion 360, talk through how that led me to updating the design a little bit, some recommendations with that. And I'll be able to use Fusion 360 to really talk through all the steps in the process and probably end up going faster than the 10 hours of video I was going to put together for it anyway. So again, new to the channel, realize that it's usually a little bit different in more machining and hands-on experience. I hope you still enjoy this video. And for those of you who are subscribers, have been watching all my videos, again, this one will be a little bit different, but I sure appreciate all of those who have subscribed and are watching these videos, watching the channel. I think you'll still enjoy this one and get plenty out of it. Haven't had a chance to subscribe yet? Hey, please hit that subscribe button. I would sure appreciate it. And just looking to make this channel grow a little bit more. But in my last video, I mentioned I had a new Tormach 1100MX on the way to help with making some knife parts. And that has made a lot of progress. So I've gone through the shop and I've done some cleanup and made room for that new machine. And I thought it was going to be June 5th before the machine even came into the US and was going to be ready to ship. But I made it just on the tail end of the May list. So I was 23 out of 24 orders. And my machine is already here, and it is already now shipped, and it's going to arrive Thursday of this week. So it made it a little bit early. Today is Sunday, May 23rd, and the machine shipped out on Friday, and like I say, it's supposed to actually get here on Thursday. So a little bit earlier than planned. I don't have time off for another couple of weeks, but I will slowly start putting out some videos of the arrival of that 1100MX and unboxing and getting that in place. It's really the second week in July is when I've got a lot of time off, so we'll see how much of it we can get assembled, put together, and in place by then. So I hope you continue to join me for that journey. Again, you want to see more about the Tormach 1100MX, good reason to hit subscribe on the channel. But today's video, before I turn the camera around and show you the shop a little bit more, what I really needed was to be able to put a dial indicator on the tailstock of my lathe and be able to measure, accurate depth when I'm drilling holes, reaming holes, doing some different things on the tailstock. Didn't want to go invest in a digital readout for the tailstock. They do make such things. Just want to make something that would clamp around the ram on the tailstock here and give a nice flat spot for this dial to push on and be able to move. So that was the intent of the project. So again, I went into Fusion 360 and made the design. We're going to go up to the computer and walk through this design in a little bit more detail. So this was the finished one that we ended up with. I actually started with a slightly different design, and I'll show you why that one didn't work out as well. Able to get some dimensions on there, and just great learning experience. So again, I've got a CNC mill coming soon, and I really need to increase my knowledge on Fusion 360 to get ready for that CNC machine. So this was a great project to get in there and design it, and went a lot quicker designing in Fusion 360 this time than last time I was in there, so already getting a little bit better, still a long ways to go. But it really helped me come up with a better design for this part. So in your own shop, if you are not using some kind of a CAD program or Fusion 360, I would highly recommend it. It is time well spent in investing in learning how to do that, the CAD system. And then you can operate things, you can move things around, and you can find out if your design really is viable, and it will save you ultimately a lot of time in the shop, and it'll save you a lot of scrap material. So would highly recommend Fusion 360. It's free if you're a hobbyist like myself, or there's some other programs out there that again are free if you're just getting started in getting into them. So highly recommend it. It'll save you time and money in the long run, I'm sure of it. This is the bar clamp that we're going to make. This is a design. I used to use something like this for line boring years ago, where it clamps around the bar that's already in place, and just took that same design, added the flat on there, and worked really well. So since we already lost the video, obviously I've already made the part, so here's a quick look at our finished product. Looks a lot like that design, and you'll see a lot more of that as there is still a little bit. I've got 2 hours of footage that we're still on the camera, so you'll be able to see making and threading this stainless steel shaft to tighten it up and the knurled end. So we're still going to make that part, and then I've got the video still of assembling all the pieces, so I still have that. But here's what I started with, just a 5 by 5 inch square on 1 inch thick of 70-75 aluminum. Obviously a very over-engineered, over-designed part for what I'm going to use it for, but it was sure a lot of fun to make, and we got to get into a lot of steps. We're going to use a rotary table to cut out the outside, use an index head to cut the little lock mechanism on the shaft. You'll see that when we get up there and talk through the design. So rotary table, index head, lathe to bore the hole, and some other lathe work to make some of the hardware. So a lot of fun. Really wish I hadn't lost all the video on it, but I think you'll still get a lot out of it as we go through and talk through the Fusion 360 design, and then get to see a little bit of making the parts. So before we head up to the computer, let me just give you a quick catch up on how things are going with prepping for this 1100 MX that's showing up here on Thursday. So if I turn the camera around, I used to have that big wooden workbench right there. It was actually just made out of a door and then had some drawers underneath. So that's what sat on the floor right there, and that is where that new Tormach is going to go. It's going to go just on this side of the door. I'll spin the camera around a little bit, get a better look. So I put in that new Husky toolbox. I had a Craftsman, I had a 42-inch wide toolbox. Needed a little bit more storage space as I took out that other workbench. So put in a 56-inch wide Husky. And also I had just a 2-drawer, an old Craftsman workbench that sat over there. So I put in another one of these rolling Husky cabinets. And underneath this other workbench, I put in another one of those Huskies for some more drawers. So cleaned up the shop, got a lot more storage space in here as I took out that workbench. And also got the wiring run for this, so came out of my panel. And I now have some outside the wall conduit, ran that all the way across and down. So now I have power for the new machine when that's going to get here. So that's where the power for the new machine. So as I said, the new machine is going to sit right here, just inside the door, and it's going to face over towards this other mill. No longer have enough room for that mill to be right there. So now that mill, I'm going to spin that 90 degrees, and it's going to back right up to the lathe. Going to set it on top of that set of Husky rollers, so that way I still have the ability to roll it out of the way a little bit. I can still get into the coolant compartment on my lathe if I need to. I can roll it. And I should end up with about 24 inches between machines. It's actually 20 inches right to the very tip on that Y-axis handle feed on the mill there. If I need to, I can take that handle off and get a full 24 inches in between machines. It's going to be tight, but that's how it's going to fit. So all cleaned out, ready to go, and that Tormach should be getting here on Thursday. And like I say, over the next few weeks, we'll see what I can get accomplished in June. Otherwise, that second week in July, I'll be for sure able to get that completely in place. There's a couple items back ordered with that. So there's a couple of items that won't be here until late in June. So it will definitely be early July before that machine is up and running and operational. Well, there's a little progress update. Hope you all enjoyed looking at how we're tracking towards getting the new 1100 MX in here. And let's head up to the computer. Let's walk through Fusion 360. Let's talk through this design that we did and show a little bit of the final footage and getting this together and getting it assembled. Really is a great little item, and it works great as what it was designed for, is to be able to give me that dial readout on my tailstock. Let's head on in and go up to the computer. Even with some lost video footage, I think we can do a really good talk through of this project since I've put it together in Fusion 360. Again, if you haven't used Fusion 360 before to prep your projects, I would highly recommend it. What you're looking at here is my first design of this project, and we ended up Ended up doing almost everything the same. I modified the latch screw because I modified this portion right here. I didn't like the way this looked. I figured that was a pretty significant weak spot right there. So I ended up changing the design after I put this together, and I think the other design I came up with was a little bit better. But I will say that from here, what I was able to do in Fusion is really understand how much clearance I need to put in here and what to do with that hinge. So was able to, move this part, articulate it, and see that, yep, I just have enough clearance right there. If I put a little angle, so I ended up making a 50 thou. It's about a 5.5 degree angle is what I went up in that spot right there. So that 5.5 degree angle, in addition to adding this radius, is what just gave me enough clearance to make sure that that was going to work. So I was able to do that. But really, it was just seeing this part in Fusion and seeing this latch up here. Didn't like the way that looked, so was able to come up with another design. So let's take a quick look at, this is what I ended up making. Put just the slot in there, you get all this extra strength. So we got rid of that weak part. And I really wanted to be able to do this up by hand. So by making this shaft longer, it now ends up up in this part. Unfortunately, this one, I'm not able to articulate and move this one right now. Still recovering from this computer crash, and until I upgrade my computer to a higher Mac operating system, I can't open the file that I made for this one. So right now I'm just looking at the drawing of it. So we'll be able to look at that. But again, modified this opening right here, put this big radius on it so you don't have to undo the knob all the way to get it to clear. And by getting this knob all the way up here out of the way, it actually makes it much better as a finger screw. Going back to this other drawing, you were really not going to be able to get your fingers on there very much, and it was going to be right up against this back edge, back up against that weak spot, so I couldn't make that any larger, and that's right at 1/2 inch. So even knurling that 1/2 inch knob, trying to get your fingers in there, I didn't think that was going to work very well. So I really like that I got the knob up here out of the way, and I think it just looks a lot cleaner with the other cutout. The other part that is not shown on this, so the other piece that isn't shown on here that I ended up making on the finished product is I didn't want this pin to fall out every time you undid it and you were moving it around. I didn't want this to fall out. So I put a set screw hole right here. So I put an 832 hole through, goes all the way through. And then on this shaft, I put it in the dividing head, and I ended up cutting a slot for about 45 or 50 degrees or so around this shaft. And I'll talk about that a little more as we sort of walk through the build on this. So how did I go about building this? Well, to start out with, I had a 5x5 inch square piece. So I just took my 5x5 square, I laid out where the center of this hole needed to be, and I put the rotary table on the mill, clamped it onto the rotary table. Really didn't think through the clamping process of that as much as I probably could have. I was hoping to put a 3-bolt circle in here and then be able to bolt this onto the 3 T-slots on the rotary table, but didn't have enough room. Those T-slots don't start until out about here somewhere, so I couldn't punch holes out here to bolt that down, so that idea didn't work. So I ended up clamping it around the outer edge, and I had this great idea. I was going to drill a hole through the middle, and then once I got it in place, I was going to put a long bolt all the way through the middle and clamp it in that one spot and move it around. For those of you already laughing, yes, you already figured it out. If I clamp all the way through here to my table, then obviously I can't rotate the piece anymore. So, would have seen that on the video if I'd have had it still. I did that total bonehead move and drilled a hole and was not able to then spin the piece. So what I ended up doing is I clamped it around the outer edge, and I just ended up having to move the clamps continuously to be able to get all the way around the outer diameter of this and get to all the places I needed to. Since I had 3 clamps most of the time, undoing one of them and moving it, it actually held pretty well. Ended up with a pretty decent finish around there and not too bad of a step as I was taking different cuts. So moving the clamps around ended up working out pretty well. So the only other issue I ran into on the rotary table is I really hadn't figured out the geometry and the dimensions to get to this corner spot. So I got it centered up on the rotary table, and then my plan was I was going to go drill a hole right through here and then mill straight up over, down, get that part cut out, and then line up back in that hole again and then machine around the outside. That is essentially what I did, but as I went to go find these 2 points to mark them, had a little bit of trouble. What I ended up doing is I came out to the diameter of this circle and I just went straight up to that diameter, and then I rotated the table. I think it was about 27 degrees each direction, punched my hole through, 27 degrees the other direction, punched my hole through, put the table back at 0, and then just manually went over and basically found where that hole was. I had a 1/2 inch end mill that I was using, so used my 1/2 inch end mill, machined all the way around this, took about it's 1 inch thick, I did 500 thou cuts, machined that, and then once I had that part done, then lined up in my spot, and I started to use the rotary table and cut all the way around. Again, going 500 thou deep at a time, just worked my way all the way around, moving the clamps around, got back over to here, and the part was off, and then it was good. So moved the clamps around, punched these holes in here, I drilled and reamed the 1/4 inch holes here, and drilled. I don't have a 1/2 inch reamer, so after I went through with a 3/8 2 flute end mill, I just punched that out with a 1/2 inch 4 flute end mill. That was basically my reamer for that hole. And then this was done. Got it off the rotary table, took it over to the lathe, just used that the 1/2 inch hole that I had put in the middle that I was going to try to clamp with. Used that in a dead center. I dialed this in on the lathe, and then I drilled and bored out this large bore right here. Once that was bored, pulled it off the lathe, and then I just used a combination, and I'll actually drop in a quick video so that this makes more sense, but I used a machinist square off of this flat surface up here, and then I used 2 parts of my combination square. I used the square end of it plus the center finding end, lined those up so that I could make sure that I had a line scribed on here that was parallel with this line across the top. All right, real quick, as I was going through the Fusion 360 video, I thought it would be helpful to just show this instead of trying to explain it. So this is how I went and marked this to split it in half. So ended up using 2 parts of my combination square in addition to this machinist square. And before this was all sanded and rounded off, it had a nice fresh square edge on top of that. And obviously this wasn't split apart yet, so it was still being held in a perfect circle. So I was able to hold that up against the machinist square up there and push the other square up against here and be right at 90 degrees to that flat spot, and then use that to come in here and set this up on center. And you can see that that was opened up about where it was. Lined that up all across there, scribed my line on there, and then just went over to the bandsaw and split it. And then when I put it in the mill and cleaned up those surfaces, it was really very, very close. So that was my quick, easy way to find the center of this circle and also line it up and time it with that flat that I had on there. Sure, there's a million other ways to do it, but this was quick and easy and definitely worked for me. Just took it over to the bandsaw, split that on the bandsaw, and then I went back, stuck this in the vise in the mill, machined these spots flat, and then after I had all of those flat, I put it back in here, held this at 5.5 degrees to mill out the angle back on there. And at that point, I milled that out, and then I went and milled out the slots on here. So flipped that over in the vise, just got them centered up, and milled a 1/4 inch slot back to about in here somewhere. So milled those 1/4 inch slots, milled the 1/4 inch slot over to line up with this cavity, and then milled the 1/4 inch slot on the other side of this piece, put this one back in, and I just had a 1/2 inch, I have a really long 1/2 inch end mill thankfully, and I was able to get all the way down and machine out this other spot to make this cavity right here. So I got that part machined out. So at that point, all the machining was done on this piece, again just in the vise, and then I went over to the belt grinder, and in the belt grinder I cleaned up this outer edge and put all these radiuses on here. So combination of a belt grinder and then a flat lap wheel to keep it nice and square and round off all these corners. Clean all that up. Used a file a little bit in here, and on mine this was actually a radius from a 1/2 inch end mill instead of this sharp corner that is in the drawing. So I just didn't go put that fillet on there, but that was actually nice and rounded. So got this outside all completely done. All these contours are done, and then it was time to go start working on the hardware. I used 1/4 inch drill rod. So again, I had drilled and reamed the holes in here. So I just used 1/4 inch drill rod for those hinge pins. I had some more 75 aluminum 1/4 inch that I used to make the hinge. So pretty easy. I just took and used that on the grinder again to round off the end ends on that piece, and then I stuck it back in the vise, and I just drilled and reamed the 2 holes 800 thou apart. Since I had gone from center on this, I had gone up 400 thou and down 400 thou. So machined my hinge holes in there and started to dry fit it together, and then it was time to go over and make these 2 pieces right here. Ended up making these out of 316 stainless steel. Happened to have some, wanted to see how it was going to machine, and also since I needed to cut that little radius notch around there for my set screw, I needed to make sure that I could keep this far enough out of the chuck on the dividing head, and I wanted to minimize wastage. I had a 12-inch piece of 316 stainless, 1-inch diameter. So what I did first is I machined this. I stuck this in the lathe, and first I cut it down to 1/2 inch, and then I parted a little piece off to make the washer. I ended up making a little washer to go in here. So I parted that off, and then I center drilled this again, had this down to 1/2 inch diameter, pulled that 12-inch piece out, stuck it in my dividing head on the mill, put the center in there on the mill as well. So that way it was sticking out of the chuck about 8 or 9 inches. So plenty of room to get my spindle all the way down and get my tool in contact. And what I did is I just stuck this in the part, and I screwed my set screw in, and I just made a mark on it when this was straight up and down. Made sure I gave it just a little bit extra so that I would, not run into my piece. Put a set screw mark in there, and then I tipped it open to where I knew that it had clearance. Screwed my set screw in again to make another mark, and then I stuck an 11/64 end mill, and that 11/64 end mill is what I used. I just went down 75 thou deep into the shaft, turned the dividing head, went from 1 mark from the set screw, just turned until I hit the other mark on the set screw, and I had a nice 75 thou deep groove in the shaft, and I knew it was lined up on the end of the shaft. I knew where to come in to drill and tap this hole, so I knew where to come over the same amount for where I had drilled and tapped the hole in here. So I got that part done. While this was set up, again, I did drill straight through the middle of that shaft, so I drilled through, tapped this hole. The only issue I had with this 316 stainless the whole time is when I first put it in the lathe and I went to drill the center hole in here, I was going a little bit too fast and pushing too hard, and I broke a center drill off in there. Other than that, this 316 stainless machined really, really nice. Didn't have any other issues with it. And some of the video that I do have left that you'll get to see here in a minute is I do have all the video of making this, the screw knob out of 316 stainless. So machining all that down, cutting that thread, single point cut thread, and then putting the knurl on here. So I do have all of that video still, and we'll get a chance to take a look at that in a minute. So that was the next piece. After that, the hardware was done. So pulled this out of the mill, cut it off, and faced off. So we had this nice latch pin created, and then I just needed the latch screw. So that's the last piece made in the lathe. And then once that was all done, then went to the assembly portion. And since I had drilled and reamed 1/4 inch holes and I was using 1/4 inch drill rod, it was just a free fit in here. So what I did to tighten those up, I used a little bit of Loctite when I assembled them, but I also went through and I center punched that drill rod a little bit. So by just popping a center punch in there, it pushes a little bit of material up to give a true friction fit and a lock. So I center punched this end of both of these pieces of drill rod, and I popped center drill holes on the inside diameter of the aluminum on the other side, so that when I pushed those together, they would spin free on the hinge itself, but they would lock into both sides of the clamp, and that way the pins don't fall out. So I hadn't done center punch marking like that for a tight fit, and wow, I put way too many center punch marks on it. So that's the other part of the video. You'll see the assembly, and I popped a lot of center punch marks around here, and when I went to go pound it together, I mean, I had to go grab a good 1/4 inch punch, and it was some pretty good smacks with the hammer to end up putting that together. So definitely those pins are not going to fall out of there. Good lock fit in there, and you'll get to see that I did a dry fit on this before the assembly, and you'll get to see this actually mounted onto the ram on the tailstock, and it operates. Dial indicator hits right here in the middle, functions as it is supposed to, and works really, really well. Now, do you need to make this out of 7075 aluminum for what I'm doing with it? No, but it sure made for a nice looking piece, and the 316 stainless on there. Really happy with how it turned out. Definitely over engineered, but was a lot of fun fun to make. And again, anytime you get to do a project where you're using a rotary table to cut this outer shape, using the lathe to bore the hole, using a dividing head to cut a lock pin on here, and then just lots of milling to clean up all the rest of this and get it together. Really happy with how it turned out. Was a really fun project. And my Fusion 360 skills improved significantly as I designed it on here and built it on here. But I will say that I think my Fusion 360 is a long way from being truly CNC ready. I noticed down here I've got a lot of these yellow blocks, meaning there's little errors in my design. You know, I've got constraints that aren't quite right and things that aren't quite lined up perfectly. So still some work to do with Fusion 360, but it's come a long way. And I think by the time that that Tormach gets here and is set up, I should be pretty close to ready to cut the first part. So hope you enjoyed taking a look at this design in Fusion. Again, the main thing being I was able to redesign this feature right here, and I think come up with a much better design for how that looks for the finished part without having to waste the material to cut that. So the Fusion modeling it in here definitely helped me with that part. I think it would help you out as well. So now let's head back out to the shop, and we're going to pick up with most of these pieces are already made, but we're going to finish making this lock screw right here, and then we'll go through the assembly part, and then we'll call it a wrap on this video. Thanks. Well, I got a quick sketch of our shaft we're going to make. So 1.189 for the threaded part at the bottom, 1.38 or 1.375, 1 3/8, half-inch diameter, and then I don't know, I'm going to go probably 7/8 for this top piece, half-inch wide there. Overall 3 inches and 64 thou, so we're going to go for right around 3 inches long, and that'll make sure that we don't have any thread sticking out the bottom. Should be good. So I'll knock this one down the 64 thousandths of an inch and go 3 inches total. So I'll go calculate what that's going to be to knock 64 thou off of that, and then we'll go with right on all our other measurements, and we should be good. Let's get our chunk of 1-inch stainless back in here. Let's knock this out. Well, we were successful in creating this without wasting any material. So since we're turning down to 1/4 of an inch on the end there to thread, we'll be able to turn all that down. So I'm just going to shove that in there. We'll face this off. We'll put that little tiny center drill in the end so that I can put my center and make sure we've got plenty of room to thread down to that. And then we'll get the rest of this turned in. Alright, that insert is dead. Change that out before we keep going. Thankfully all that's getting turned down to a different size. Now for this one I need to go 1 1/8 plus 1 3/8, so that's going to be easy enough, 2.5. So I need to feed back to 2.5, and I'm going to 1/2 inch, which should pretty much be what I've got right there. Let's keep going with those 125 cuts. All right, we're going to total depth of thread or total depth of 46 thou. And well, I am not able to cut that with this tool with the center in there. Well, we're not going to be cutting threads that fast. Okay, this is going to work fine. We'll just do this to cut our threads. I don't need threads all the way to the top because it's got lots of space in between, so I'm not going to come anywhere near our edge. I'm just going to do my undercut right there, and I'll thread into my undercut. Actually, I mean, I really only need threads for, what, a little over 1/2 inch. Let's just go to there. The rest of it's all the space in between. Let's thread right to there. We're going 46 thou deep on a 28 TPI thread. So I'm going to go ahead and touch off, and I will go in 50 thou, make a little undercut, and then we'll come back and we'll get started on our threading. Let me get this set up for 28. Get my thread dial engaged. And for 28, I can engage in any position. Okay, super close. Give a couple more cleanup passes there at depth. Oh, it's going, but it's snug. We don't want it that tight. Let's clean that up a little more. Now that is just nice. Okay, we've got threads. Just a good friction fit all the way down. All right, last step. Let's get our knurl on that last little section, and then we are pretty much done. Now, as I learned from last time, my knurling tool likes to leave a little bit off, so that's why I left some room. We're just going to go past where I need to knurl, and that should give us our good knurling pattern where we need it, because I only need 1/2 inch, and we've got 7/8 of an inch there to play with. But let me get this back into regular feeding again, and I'm ready to feed the right direction. All right, that knurling tool really is too low. Work on fixing that to start with. Alright, I didn't like that diameter. Let me try a little bit different. It's just really double knurled and made a mess there. So let's shave a little bit off. Try again. Okay, I think that's looking pretty good this time. Let's run a couple passes and see how it does. Okay, that's a good looking knurl. I thought I was going to have enough clearance over my tool, but I did not. But I think we made our 1/2 inch. Pretty close, not totally. All right, I've had good luck restarting a knurling tool before. So let's see what we end up with here. Need to straighten this back out because I can already see my knurling tool move that. Okay, should have stopped and looked before I shut it off, you know? Okay, now I got a good looking knurl far enough. We are there. Get a nice clean edge on that knurl. We'll turn this around. We're gonna cut this off and face it and there we go. Now we're all the way into it. All right, let's get that cut off. We'll come back and face it, and then we can just Loctite and assemble this baby. That's what it's looking like. Nice looking knurl in there. We're only going to use that much of it, so this part where it tapers off on my knurling tool will be all right. So we've got a nice clean edge. Yeah, I think that turned out looking very nice. Let's get it cut off. I think 1/2 inch is plenty on that. I think we're just going to face it down until it looks good. Probably go a little bit less than 1/2. There it is. Just eyeballed that bevel in there the same as the other side. And there we go. There is some stainless. Threaded, drilled and tapped on our other piece. Not too bad to work with. We only broke one center drill off in there and it still knurled nicely. All right, let's go get this thing dry fit together, see what it looks like, and then we'll head to the bench and we will do a little bit of center punch marks and get it Loctited all together. I would say that is a fit. Yeah, that's nice. It's just a little bit below the top. Plenty of room to get your fingers on there. It's a good size to get that tight. And you only have to loosen it off just a little bit, and because of that bevel, it swings out of there. Only swings to there. Plenty of room to get that off. And it's not falling out of there. Our little stop pin is working just as we designed it. Now it goes past and where it's totally in that pocket, but let's see where it's lined up when it's on here. Yeah, when it's tightened up and it's on here, it's just got a little bit of clearance on that backside. We put our dial in place. And we've got good dial reading as we move that in and out of there. Success! Alright, so we need to do a little bit of cleanup with some acetone, get all the oil out of here, and then we will center punch these two pins to get those to lock in, and we will Loctite this set screw in there to make sure that that's not backing off. But there it is, a bar clamp, and there's why we're Loctiting the pins in there, because otherwise they just come out. So there's a bar clamp. Very versatile item. You can use it for lots of different things other than just for this center tool. As I said, I used to use these for line boring. Make a clamp, go around the bar, and then you'd make a holder for your tool bits. And easy to get these on and off the bar. You can make them in different sizes as your hole got bigger. Works well. All right, let's get over to the bench and let's get working with some center punch on these and Loctite, and then we'll call this a wrap. So this is kind of like knurling. It's just going to raise up, it's displacing that metal. So it's going to push that up a little bit and make this pin a tight fit in that hole. And give a little something for that Loctite to catch on to. So yes, that's going to be a nice tap fit to go in there now. So we'll do the same thing to the other one. And I'm going to assemble this as if it's looking at me. So I'm going to push them through this side. So I'm also going to see if I can't get into the back side of these holes and just put a couple center punch marks from the back side here so that the other half of that pin will catch on them as well. Go get that to the vise. Or actually, just go with a better hammer. I knew that was going to lock those pins in there. I was not expecting it to get quite that tight. But hey, that definitely accomplished the goal we were looking for. Those pins are not falling out of there. We still have good movement. A little tight on that one right there. But opens up, it'll get around our bar. Still have hinge movement. So there's the center punch trick to tighten up those pins and lock them in there. There it is. Complete, Loctited. We'll leave that till tomorrow, really make sure that Loctite sets up in there, but I think that is pretty snug fit, so very happy with how that turned out. Again, these are pretty versatile. You can use them for other things. So hopefully that gives you some ideas. We went through lots of machining steps in this video. So we had rotary table to cut out the outside shape. We used the lathe, dialed that in with a dead center to get that bore on there. Back over to the mill for all of this, cutting it in half, drilling all these holes, notching it out, getting all that done. A little bit of work on the grinder to clean up that outside edge. And back to the lathe to make some of these parts. Back over to the dividing head to get that little lock in there, but I think that was a great addition. Keeps that piece from falling out, so I think definitely worth a little bit of work to knock that out. We got to mess with some stainless steel for threading, knurling, making some parts. And yeah, all in all, there was a whole lot of steps in this one. So I hope you enjoyed the video. As always, thanks for watching these. If you like them, hit that subscribe button on the channel. You can see more steps in machining, more parts like this. I know I've got some knife videos coming, but this was a great step towards practicing for my new Tormach. Got to use Fusion 360. We got to work on a couple of designs. We got to refine this design in Fusion 360. So just really a good all-around project to practice lots of different things. So again, you like the channel and want to see more videos on machining, welding, everything else going on here in the Blades to Be shop, please hit that subscribe button. And until I see you next time, I hope you're out in your own shop working on some projects of your own, maybe making one of these if you need one, or just making some other chips in general. So until next time, take care.